Hi students, let's look at this question here, which was taken from the year 2018, the school HCI J2 mid-year exam question 5. This question is on complex number, so it's asked by one of the students. So let's see how do we do the first part. Right, you're given that the complex number u and v such that u minus 2vu plus 2vi is a real number. In other words, the imaginary part of this value here is real. So the imaginary part of this number here is 0 lah. Sorry, so this whole will be 0. Now straight away I could see that some students will just equate this to 0, which is not right. You can only equate this to 0 if these are all like all real number, right? But these are complex numbers, so once you expand it, they are like imaginary parts as well. So you're asked to show that mod u equals to 2 mod v. So let's see how can we solve this properly. Now at the start, you need to decide which type of complex number you're going to use, whether you're going to use trigo form or you're going to use Cartesian form or even the exponential form to solve. But I would suggest for this case here, likely the Cartesian form would be the easiest path, because you can actually just use algebra and try and solve it, right? And essentially just equate the imaginary part to be 0. That's your whole idea there. Okay, so we're going to start by doing, so I'm going to let part A, so this part here, I'll just let u equals to a plus bi, and I'm going to let v equals to x plus yi. Okay, so this is okay. So mod u would just be a squared plus b squared, and mod v would just be square root x squared plus y squared. So this is okay. So you need to show that basically you need to show mod u, which is actually a squared plus b squared equals to 2 of x squared plus y squared. So just keep in mind that this is what you need to show. Okay, so what I'm going to do is actually just copy down u minus 2v u plus 2v. I know that this complex number here, this is a whole complex number with the I, please mind you, so you should include the whole I, and then you just substitute it in. So this part here, I'm just going to write u would just be a plus bi minus 2x plus yi, and then divided by a plus bi plus 2x plus yi. Okay, now your whole equation here is to make sure that everything is being segregated to the real part and imaginary part. Okay, so what I'm going to do is I'm just going to simplify the top, which is a minus 2x. This is my real, and this will be b minus 2y I. Okay, just bracket it as such. The bottom similarly be 2x plus b plus 2yi. Okay, now I'm going to simplify this by multiplying this in first so that it's not so confusing. So this part, if I were to multiply this in, what I'll get is essentially just b minus, okay, maybe I should just a minus 2xi, I squared will be minus, so b minus 2y. So the b minus 2y initially was like imaginary, it just became a real value. Okay, so this part here, once you get it, will be like that. Now the next part will obviously be multiplied with conjugate, right? Conjugate. So in other words, what I'm going to do is I'm going to multiply the conjugate of the bottom, which is actually just multiplying with a plus 2x minus b plus 2y I, and similarly with the top value here, a plus 2x minus b plus 2y I. That's the value there, right? So I'm just going to slowly multiply. You don't really need to worry about the denominator. Basically, if okay, I'm just gonna, because actually you don't really need to expand the one below, but we're just gonna write this as like that. But b plus 2yi, this will be a minus 2x, a plus 2x I. Expand it will be, I'll just skip steps in expanding. This times this will just be minus, and this will be a plus 2y, b plus b minus 2y Okay, so this is the whole complex number here. So maybe the bottom one I should have just taken this out. Take this out and put it here. So a bit OCD, but it's okay. So now take note, now the imaginary part, since the imaginary part is the imaginary part of the number is 0. So in other words, this part, just take out the imaginary part. There's just the top will do. The bottom don't really care because you don't really need. So hence this will imply that a minus 2x, a plus 2x plus b minus 2y, b plus 2y I is equals to 0. So from here what you're going to do is actually 0i lah, if you want to put it. But anyway, you just get a square minus 4x square. You can remove the I, 0. So a square plus b square equals to 4x square plus 4x square, which actually will imply that if you square both sides, it will just be square root a square plus b square equals to square root of 4x square plus y square. And this would yield 2 squared x square plus y square. And this would actually be my mod u to mod v. Okay, that's how you show it. Alright, here's how you show it. Now yeah, you could just actually, I would suggest, if you can, you just keep the expanding the rest. So just take the imaginary part out and just equate it to 0. Okay, so that's how you do the first part. This is pretty okay, I think. Now let's look at how do we solve the second part. Right, you're given that, look at the b. It's given that z is this without using calculator. Express z in the form of rei theta. Okay, and then find the smallest positive such that zn is this yada. Okay, so how do we do that? All right, so that's a question. And how do we express that? Okay, let's try. Now it's very, you need to express the formula here. So it looks like basically z is equals to cos theta plus I sine theta, right? The problem now is because there are like two cosine values here, so it's going to be very, very complicated. I would suggest just bring out your MF26, bring to the so let me show you how to go. So from here, what I want you to be able to see is with this MF26 here, all right, what you're going to do is basically just go to the addition formula, which is here. Okay, I'm just going to eyeball this bit, this addition formula. So let's see whether I've got. So from the MF26, I'm just going to use this factor formula here because I want to find what could I make use of it. Likely you just have to use it, so the triple factor formula would be this, right? So if you look carefully, so basically we have got cosine and cosine here. Okay, so cosine and cosine here, cos plus cos will give us a cos, so that's all right. So you'll be able to change this to cosine, and then this is sine theta, which we change this, it will just be a sine and cosine. Okay, so that is how we're gonna try and see how we're gonna solve this. But I think it's quite promising, so I'm just gonna try and see how do we factorize it out. Okay, the first thing is basically understand that to get this formula here, this average it out. So z, this part here, I'm going to use this formula. This part here, cosine plus cosine. So cosine plus cosine will be 2 cosine, add them up, so it will be 10 over 16 pi over 2, p plus q. Then this is cosine, minus them out will be minus 5, 3, or minus 4, sorry. So negative 4 over 16 pi over 2. Okay, that's one. So I got the cosine and cosine. And after that, we're going to get sine and sine. Alright, sine and sine will be plus I. This would be this formula here. So this would be 2 sine, add them up. So it's 10 over pi over 12 over 2. And then minus them, the difference, divided by 2. So minus 4 over pi, 16 over 2. But I'll suggest that if you concerned about the what do you call it, the negative sign, you could just swap the position, right? But it doesn't really matter because what you need to know is actually cosine theta. Cosine negative theta is actually cosine theta. So this is cosine is okay. I mean, we don't really care whether the value. Okay, so this is what we do. Once we've done that already, we're gonna get 2 cosine. This will be 10 over 16 divided by 2, which is actually just 5 over 6 pi. This is cosine 24 over 16 divided by 2, which is actually minus 1 over 8 pi plus 2I sine. Similarly, the same angle, so 5 over 6 pi. And we have got a cosine minus 1 over 8 pi over here. Okay, so that's one. Right, once we get there already, we are quite okay because we could, I could see that we could factorize this out. This could be factorized out. So I'm just going to factorize this and this out. And obviously, I could also factorize the 2 out. So just factorize them out. This part here, we're just going to get 2 cosine. Oh, so this is pi over 8 because cosine minus pi over 8 will just be cosine pi over 8. That's okay. So this part here, what we're going to get is cosine 5 over 6 pi plus I sine 5 over 6 pi. Alright, once we get that, we are okay. Then what we're going to do next is basically express this in terms of Euler form because that's what they want. So this is cosine cos pi over 8, and this would be EI 5 over 6 pi. Okay, so that's that. This is EI pi r pi theta. That's the answer. Now, if you got any question, please let me know. Okay, I know some, but basically this is a real number. That's why you could leave this. This is our r. So the r is you could not contain any I. So once you get there already, hence find the smallest value positive Zn, smallest value n such that Zn. Okay, great. How we do that? So basically, what we need is basically Zn is equals to k minus 1 minus I, right? Find the smallest value n such that Zn is equals to ki. Okay, great. So what you could do is actually just try and see how I think the argument would do. The argument would be pretty cool. So n, right? So we just argument both sides. Argument Zn is equals to argument k minus 1 minus I lah. This is how we do it. So this is n argument z, and this is argument k plus argument minus 1 minus I. This is negative 3 over 4 pi lah. Okay, so minus 1 minus I. K argument, is it a real positive number? Some positive real number. So since k is positive real number, so this would be k is positive real. So hence argument k is real 0 lah. So this would be n argument z, which is actually just 5 over 6 pi equals to 0 minus 3 over 4 pi. But obviously, because you need it to be a multiple, means the argument can be like 2k pi of it, right? So I'm just going to use like 2 because they already use n, so I'm going to use is there n being used, n also being used, so plus 2a pi means a multiple where a is okay, where a is a integer value lah. A is an integer value lah. So the argument that you want to get, you just keep adding 2 pi to it. So it's okay, this part here. Once you're done, I'll get a 2a pi behind, and this is plus 2a pi behind. So I get n 6 over 5 minus 3 over 4. All the pi's are being taken out. So this is my n. What I need is find the smallest positive n integer. So n has to be an integer value. So I'm just going to key in calculator for this and find the integer value. The easiest way is just use calculator. But if you do not want, you could just deduce how does this become an integer value. But I don't think is that far. So just use a calculator. No harm using calculator. So 6 over 5 minus 3 over 4 and basically plus 2x. That's all you get. Then second table. Alright, so you find the smallest positive integer. Smallest positive integer. Is there an integer value here? No. Come on. Okay, let me see. Okay, I managed to find where's my mistake. My mistake will be here. So sorry. So this is 16 and this is 16 and all these are 5 over 16. I came wrongly. So this is 5 over 16. This is 5 over 16 and this will be 16. Okay, so there you go. So in other words, n would be the smallest positive from GC. So what I did was I just key in this lah. Just key this in. I changed 16 over 5 and 2a. So table value this will be 1, 4. So GC smallest positive and integer is equals to 4. Okay, so yeah, that's how you do this question here. If you have any issue and any comment, please let me know. I'll try and help you and rectify it. Okay, keep practicing. See you in the next video.